Awesome. Hi, everyone. I'd like to talk to you about static application security testing today. Um, Basically, we adopted certain techniques in our company. May work for everybody, may not, but I wanted to kind of go through them and hopefully share some of our experiences to see if you can help. And at the same time, I wanted to listen to your experiences as well over time if we can. Um, Quick intro about me. I am Sid. I started out in AppSec research, spent some time doing deep dives and creating detection algorithms for dynamic and runtime scanning tools. And about 3 years ago, I moved into real world AppSec. So I'm part of a security advisory team, and I also help figuring out process improvements for AppSec engagements in a larger organization. Before we move forward, I just wanted to give a quick shout out to Ray and Aaron for putting this together and everyone else involved in HellaConf. Thanks a lot, guys, for getting this together soon. So with that, quick intro into static testing. I'm sure most of you are familiar with this. There are different techniques that static analysis tools use to detect vulnerabilities in your source code. The most common technique that I wanted to talk about here is called data flow analysis. And data flow analysis uses a technique called taint analysis. So there are three different kinds of methods that are used in taint analysis. The first method is called a source method. Now, this is where we expect untrusted input to get into your application. So think about it as request.get parameters. So anything that comes through a query parameter is considered a source. A sink is a method where we expect the vulnerability to manifest itself. So in the case of SQL injection, this would be an execute SQL method, right? In the case of cross-site scripting, this would be a response.write method and so on. And then the third type of method is called a cleansing method or a sanitizing method. Now, this is a method that's expected to convert that untrusted input into a trusted input. So again, in the case of a SQL injection data flow, a parameterization method would be considered a cleansing method. So anything that passes through that cleansing method is now considered to be safe. Similarly, in the case of cross-site scripting, an encoding function could be considered a cleansing method. So the way the detection works is that if a taint, which is introduced at the source, makes it all the way to the sink without passing through a cleansing function, then that data flow is considered to be potentially vulnerable. This is one of the techniques that's used in static analysis, and we'll see why this is relevant as we go forward. So quick call out on the biggest pro for static analysis, right? Any advocate of static analysis would vouch for this, saying that it's a great way to shift left in our SDLC. And this is completely agreed upon. Most tech tools that are built around static analysis easily lend itself to be able to automate it into our current SDLC and dev processes. And so it's just easy to introduce automation as early as possible in that life cycle. In addition, there are multiple tools and research available already since the technology has been around for a while. So we have both proprietary and open source tools, and we also have libraries today which you can use to build your own static analysis techniques on top of if you need to. However, if any of you have dealt with static analysis scan results in the past, you can all vouch for this, that the false positive problem is the biggest problem. And this is rightly so. In the SAST philosophy, the concept of finding more is kind of ingrained into it. And one of those reasons is that data flow analysis that we saw, right? There are certain inherent flaws in that, but it is intentional so that we can avoid missing out some of those true positives. So there are multiple reasons. I just wanted to call out a few. There are cases where there could be unknown cleansing methods in your source code because maybe you have a custom cleansing method that was defined, or maybe you just have a different technique for whatever reason, right? There are different corner cases for applications. You could have irrelevant source sink pairs. So there might be certain sources and sinks that are considered valid from the default configuration for the static analysis tool. However, for your application, it might not make sense. And finally, this is very common in more modern applications. It's getting harder and harder to construct an accurate data flow because of dynamic code injections and annotations and so on. So building that call graph out is getting harder. Now, there are advances in research that's going on here, but noticed during my experiences that there are definitely flaws there where you just don't have the right data flow in place. So with this in mind, this is basically based on what we've observed. I wanted to just go through a few steps on saying, how do we onboard an application, be it a brand new application or a legacy application that's been around for a while, into a static analysis process? And along those lines, we'll also go through a couple of use cases as well. So first thing is to start small. I know it sounds really obvious, but when we are so overwhelmed with all the AppSec work that's going on, it's very easy to just throw in a scan with standard configurations that come out of the box. Say we're automated, we have some scan results and we're good to go. And then we just get back to triaging it months and months later, and we realize that it's just not what we were looking for. So starting small is saying that we start with that sandcastle. We're not trying to build an entire citadel from scratch. So identify those high value issues that you think make sense. Maybe you have information from past engagements for that application. Maybe you've done some more recon on your own, or you could just use OWASP top 10 out of the box as well. Any methodology, but you want to start with a few set of vulnerabilities that you want to detect, and then you just grow it from there. Next one is to verify the data flows. We did speak about in the cons how there could be inaccurate data flows. So it's not going to be possible to exhaustively check all data flows, but try to spot check some of those, especially areas where there are external dependencies, annotations, and so on. If you are familiar with custom cleansing functions and so on, that's also something to quickly look out for. And if you have good relationship with developers, this is a great point to involve them into the process, because they have a lot more context of what's going on in that source code, and they might be able to point you in right places. So if you have a security champions program in your company, great, you can involve them. If not, at least developers who have that inclination to get into security would be a great point to have that engagement here. Now that we have the scan results, we're going to start triaging, right? And again, by this time, even though we start small, we are probably looking at 4-digit or 5-digit number of issues, depending on the size of that application. And we know for a fact that majority of them are going to be false positives. So how do we prioritize these issues? Now, this is going to be dependent on your application itself. The biggest thing that any automation tool misses out is the context of that application. So this is where we as AppSec engineers, and hopefully the developers as well, can kind of bring in and say, we know which areas of the application are more at risk. So let's start there. And obviously we have the severity of the issues itself that are in place. So with the combination of these two, hopefully you're able to slowly chip away on those results that are coming in. Now with this, I want to move on to some of the more advanced areas of static analysis, primarily talking about custom rules. Now, majority of the tools out there, both proprietary and open source tools, allow you to create your own rules. You can create really complicated rules with logic and conditions and so on, but the simplest rules would basically be able to say that you're going to provide your own sinks, sources, and cleansing methods for a specific type of vulnerability. So this is an easy way to kind of provide that application context that was missing in your application, in your scan, and just be able to tailor that scan for your app as you go forward. So at this point, let's dive into one of these use cases. So in one of the real world applications that we were looking at, Open Redirect was a really big problem. Now, quick primer into Open Redirect. This is a very common pattern in applications. You could have a redirect URL as a query parameter that gets passed to the application. After some action is performed by the user on that page, the app tends to redirect that user to whatever URL is present in that query parameter. As long as it's a relative URL, you're fine. You're going to be within the same application context. Sometimes apps need to switch between different applications. So at that point, hopefully you have a whitelist of domains to make sure that you're not like going into malicious.com or something like that, right? However, if you see that second line, that is kind of the pattern that we were looking at in our application. We were using response.redirect, which is a valid sync. And you can see that the URL actually made it into the argument. So from a data flow analysis perspective, that looks vulnerable. However, when you look at it closely, you can see that the host, which is the domain for that redirect URL, is already configured into the application. It's not user controllable. So if you actually pass in an absolute URL and the query parameter, this is just going to error out. Looks dangerous, yes. Exploitable, not necessarily. So how do we kind of weed out this false positive? Because we were seeing hundreds and hundreds of these, which is just a lot of noise. So we did take some assumptions, but the way we addressed this is we created a custom rule that said, yes, we agree that response.redirect is a sink. However, we're going to consider it to be a cleansing function if a couple of conditions hold true. One, the argument that gets passed into that method is created by concatenation, either within that line or somewhere before that line as well. And then as part of that concatenation, the first part of that concatenation is always going to be a constant. Now, there are a couple of ways to do this. You can just assume that it's a constant string. However, there are going to be cases where you would have HTTPS plus a parameter, so that would still allow user controllable domains. So you can actually take it a step further and also try to validate what the exact parameter is, and is it actually containing a host or domain. When we implemented this and put it through, it removed hundreds of false positives, but more importantly, it actually cleared all those noise out. So we were immediately presented with more than 50 true positives on that same application. So with a little bit of time and research put in, we really saw quick value that came out of this. This was a sensitive application too, so we were glad we were able to find this. Now, the second use case is SQL injection. I know it's 2020 and we still keep talking about SQL injection, but unfortunately, this is still valid for a lot of apps, especially if you're dealing with legacy applications as well. So without going into the details of the vulnerability itself with the time, I want to make sure that we're talking about the case that we were dealing with. So we were looking at an application that did have concatenated queries. It did accept parameters that were getting concatenated as part of that string. However, there were no user inputs coming in. Most of the false positives turned out to be because the source that was configured that came out of the box was not appropriate for that application. But at the same time, this was also a lot of noise, and it could be potentially dangerous if there was a user parameter coming in. So we wanted to look into this deeper to see what was exactly going on. Now, the data access layer in the application provided two methods for how you wanted to execute SQL. One accepted a SQL string plus a list of parameters, and internally it was parameterizing it before sending it to the database. And then the second method would just accept a SQL string. And internally, it was just calling the first method with an empty list of parameters. So the pattern that we noticed was that a lot of developers just concatenated their SQL query and then call the second method. And this seemed to be like a copy paste. So over time, many modules started using the exact same pattern. So we took a two-step approach to solving this. The first one was a quick hit where we said, we're going to identify every place that's using that second method in their data flow. We also kind of cleaned up some of our sources to make sure we didn't have unnecessary sources, considered cases for second-order SQL injection. But the biggest value we saw was in saying that if there is the second method, execute SQL, getting called with a concatenated string on the way, then we wanted to review it. Did we have false positives still? Yes, because there were queries that did not really have any user controllable parameters, but at least we were able to identify all the modules that were using that second method. Now, the next step kind of takes us into a more advanced area here where we're saying we want to mature this process more. So let's establish design patterns with the engineering team. Now, this is hopefully in the case where we have good engagement with the developers. So we're able to come to an agreement on how coding best practices need to be implemented. So after multiple discussions, we decided that we were going to rewrite the data access layer so we could actually enforce parameters, obviously with accommodating for queries that did not allow parameters. So what did this look like? We basically removed that second method. We said that anytime execute SQL needs to be called, it has to be that first method, which means you have to send in parameters. However, for cases where you did not need to use parameters, you expect the developer to send in null. And then we had a custom query that basically looked for this method with null as that second parameter. So now we're greatly reducing the scope of what we're reviewing to cases where there really aren't any parameters sent. So if there's a developer who's concatenating a query, just sending in that with a null, we should be able to catch it. Now, is this bypassable? Yes, a developer who wants to intentionally bypass this query can easily do so. But this is where I want to bring up about, this is just the technical aspects of this, right? We want to think about how we're solving these problems across people process technology. So we want to make sure we have that relationship with the development teams. We have that engagement with the people. We are able to come up with a consistent process that's getting used across security and development in terms of best coding practices. So this is kind of what we agreed upon for SQL injection and open redirects. And then we use the technology, which is our static analysis tools and custom rules, to make sure that we are enforcing what was agreed upon, and so we can catch those outliers. So this is something I definitely want to call out as a caveat. Now, finally, as with any process, you got to continue, rinse and repeat, right? Just make sure that you're expanding the scope. If you remember, we started small initially to make sure that we wanted to really scope it down. Hopefully, we have a prioritized list at this point, understanding what is really important for that application. And so the goal here is to be able to say, let's go down that list. Let's address one at a time, and hopefully over time expand that scope to most of the high severity issues that you have in your application. Now, the important thing I want to call out here is for every issue that we are triaging, we're obviously creating a sort of baseline. So we're able to identify all the true positives, remove false positives, have a clean scan. But the value of that baseline is not in all the bugs that we file during this whole triage process. The value is in how we are using that baseline going forward. Because we are under the assumption that after the baseline's done, you still have automation where you're continuing to scan and catch new issues coming in. And the baseline is a snapshot in time, right? Great that we found all the old vulnerabilities, but the best way to keep that software secure going forward is to use that baseline to continue catching new issues over time as code continues to get developed. So this is where we see the biggest value in that baseline. So with that being said, thank you for the time. If you have any questions, please feel free to shoot it over. And if you have more experiences to share, I would love to hear more. Feel free to post those on Twitter as well so we can continue the discussion. Thank you.